All right, class, let's begin. We are now, let me get my pin correct here. Yes, we are on. We are on the half angle formulas. Let's go. So we want to be able to get half of the angle that we have been doing so far. So let's see what that all means here. But before we get there, let's go back to look at the double angle formulas because that just might help. If you guys remember, let's start off here. So the double angle formula for sine, anybody know that one real quick here? So sine of 2 theta, I guess that's the way we wrote it. It was 2 sine theta cosine theta. Okay, and then, because there was only one formula for sine, right? Double angle formula for sine. But for cosine, there were, anybody? There were 3 different formulas for cosine. And I just got to find them real quick here. Okay. And we got cosine. I think we used the letter A in here, but we could use theta. We could use any kind of thing in here. So we have ourselves this formula, because remember that was one cosine squared theta minus sine squared theta. That was one formula. And then there were 2 more. The other one was cos2 cosine squared theta minus 1. And then there was 1 minus 2 sine squared theta. That was perfect. So there was actually 3 in here. So those were the double angle formulas. But what happens here is the double angle formulas actually help us to find something called the half angle formulas. So what we're going to do, just to start off with, I'm going to just write both of them. So here's all our double angle formulas. So 1, 2, 3, 4. So what tends to happen is we find the double angle formulas or the half angle formulas by looking at the double angle formulas. Let's start off with this one here on the bottom. This guy. Is there a relationship between cosine of 2 theta, so a doubling of an angle, and then the single angle? Yeah, we've used this. Let's take that one and we'll kind of work our way through proving it. Now, just real quickly here, you don't have to memorize the proof for this. This is just our proving it, and then we're going to use it. So that's what we want to get to. So here's what we're going to do. We are actually going to solve for sine theta. And then we'll see a little trick in here. So I want to solve for sine theta here. So what we do here, we are going to subtract 1 from both sides. Get ourselves cosine of 2 theta minus 1 is equal to negative 2. Oh, that's interesting. Negative 2 sine squared theta. Let's divide this guy by negative 2. All right, if we divide by negative 2, first of all, that cancels. And my left-hand side is left with sine squared theta. This one, we can kind of move the negative out in front, or we can do is we can switch all the signs on top. So let's kind of do it in both ways here. I'm going to move the negative in front, so it'd be like this at first. Let me show you all the steps here. And we get this. And then what we're going to do is we're going to multiply the negative into this. So now we got ourselves negative cosine 2 theta plus 1 over 2. And we generally don't like it to look like that. Well, that was a very squirrely little theta here. How does? Let's rearrange these numbers here. Let's put the 1 first and then this guy next here. So the next slide, got myself 1 minus cosine 2 theta over 2 is equal to sine. Oh, and this is still squared. That's the thing. This is still squared. So guess what I'm going to do? I'm going to take a square root of this side, plus or minus, And I'm going to do the square root of this side, plus or minus. Because remember, whenever we take the square root of both sides of an equation, we have to put the plus and minus here. And this little square root and this little square cancels. So now we're left with sine by itself. And we're left with this one exactly the way it is right now. We're going to leave it just like that here. Cosine 2 theta over 2. Let's switch it around. So sine theta is equal to plus or minus 1 minus cosine 2 theta over 2. Okay, I'm going a little fast. Hopefully I can slow down now. So how has this helped us any which way? Helped us by this one little trick. And again, Hipparchus on a Saturday morning. It's raining outside. The fireplace is going. He has nothing else to do. And he's thinking about trigonometry. And he's thinking to himself, you know what? This actually connects. Hold on. This theta here is half of this theta. Because that's 2 theta, or this angle. So he makes this little conclusion. He goes, you know what? I'm going to do this here. I'm going to say that a over 2 is going to be my theta. And if that's the case, then hold on, that means 2 theta is going to be equal to a over 2, which is literally just going to be a. So let's see if we can rewrite this whole equation on the next slide here. I'll just write it down here because I do want to sort of see the connection here. So that means I have this now. So I got sine of a over 2 is equal to plus or minus 1 minus cosine a over 2. And Hipparchus on a Saturday morning just developed the half angle formula for sine. And it was just this little trick to see the fact that he had a double angle formula first, and he just solved it for the other side. Okay, now what this allows us to do is to figure out half of an angle. Okay, let's do that here. But before we do that, before we get to an example here, let's go to this whole concept here of how come the plus and minus here? What's up with that right there? Why do sometimes we do a plus? Why do sometimes we do a minus? It all depends on what quadrant you're in. So let's talk about that first because that needs to be settled. And this will work for sine as well as cosine. I'm going to do this here. If I start off with an angle, right? Let's just say theta is my angle. Okay. I want to know which quadrant I'm in when I take half of it. So here it is. So if I start off with the angle of theta in quadrant 1, the question is, if I take half that angle, which quadrant would I be in? And that's going to determine whether it's a plus or a minus. So let's do some angles here. If I were, let's say 60 degrees, and I take half of that, notice I am in quadrant 1, right? Actually, I should write it like this. Element of quadrant 1. If I take half of 60, I want to be at 30. I'll be over here. It's still in quadrant 1. Absolutely. Okay, so let's do this here. Let's get really complicated. Let's go up to like 80 degrees. Doesn't want to erase. There it is. Whoa, that was loud. How about this? I'll go 80 degrees. Is that in quadrant 1? Absolutely. If I take half of 80 degrees, what quadrant will I be in? Well, half of 80 is 40. I would still be in quadrant 1. Okay, so we did this here. If my angle is in quadrant 1 to start off with, half of that angle would still be in quadrant 1. Okay. All right, let's try the next one. It becomes obvious after a while here. So let me choose an angle in quadrant 2. I'm going to choose like 120 degrees. That is 120 degrees. And because of that, the terminal side ends in quadrant 2. But here it is. If I take half this angle, that'd be 60. So if I'm in quadrant 2 and I take half my angle, I wind up with an angle that's back into quadrant 1. Okay, let's test this theory on some higher angles. We did 120, but let's just test with a bigger angle. Let's go like 150. Okay, so 150 degrees for this angle. Half of 150. Original angle is in quadrant 2. When we take half that angle, it turns out to be back in quadrant 1 because it's 75 degrees. Okay, so I think we can rest assured if our angle starts in quadrant 2, half the angle will still end up in quadrant 1. Which makes sense, right? Because the highest you could ever go, like all the way to the border here, would be 180, right? And take half of 180 to go back down to 90. Okay. All right, let's go into quadrant 3 now. So I'm going to choose an angle here in quadrant 3. I'm going to say this is 210 degrees. 210. What is half of 210? So this would be in quadrant 3. And take half of 210 would give us 105, which gets us back into quadrant 2. Okay, let's get some bigger angles. That was 210, but let's go to like 240. That's an angle that we know of. That is still a quadrant 3, but half of that angle. So half of that angle, well, that'd be 120. That'd be like right over here. Okay. So any angle that starts off in quadrant 3, if we take that half that angle, would wind up in quadrant 2. Tell me if you guys agree with that. Okay, and then let's do the last one here. I'm going to start off with an angle in quadrant 4, an angle that I know. 300 degrees is fine. Boom, 300 degrees. We're right here. We start off in quadrant 4 to begin our angle. If I take half of 300, that would be 150. We get right back into quadrant 2 again. So I think we've just at least showed here that if our angle starts in quadrant 4, we wind up still in quadrant 2 if we're taking half our angle measurement in one revolution. Okay, let's go just a little bit further. Let's see. Let's make a bigger angle here. Let's make that into, let's see, 330. How about that? 330. What's half of 330? I don't know. I got to do it myself here now. That's going to be 1. 6, 5, I believe. Is that right? Just test me here just to make sure. Yeah, 165. So again, if I take an angle called 130 or 330, if I take half of that, it will wind up right over here, still in quadrant. Okay. Keep that in mind as we're going to do the exercise problem here. So exercise number 1. I need you to find the exact value of sine of 105 degrees. Now, interesting thing about this, I'll let you guys write it down first. This particular angle measurement, I think we've done this before even. We actually can find this by adding angles together, right? We can use the sum formula. Isn't sine of 105 the same thing as sine of 60 degrees plus the sine of 45 degrees? I think we actually did that on notes before. Yeah, you can find sine of 60, find of 105 by taking sine of 60 plus 45 degrees and using the sum angle formula. You can also do it by doing the half angle formula. So the question is this: 105 is half of what? So we say, hey, sine of 105, 5 is half of 210. Do we know the half angle formula? Absolutely. So here's what we got to do. We got to decide, first things first, we got to decide here, do we put a plus or do we do a minus inside here? And it all depends on where we land or what we started with. So if we say, hey, we started at 210, this is what we did on the previous slide here. If we originally started quadrant 3, where did we end up at? Let's go back to our slides here. So it's this one right here. If we started quadrant 3, we'll end up at quadrant 1. So now the question is this: is sine in quadrant, I'm sorry, not in quadrant 1, sorry, in quadrant 2. So our angle ended up right here. And we know the angle because it's on 105. We know 105 is here. But in quadrant 2, is sine positive or negative in quadrant 2? Well, since sine is controlled by the y-coordinate, it is positive. Right? Because the cosine is negative, but the sine is positive in quadrant 2. So what we're going to do is we're going to put a little plus sign. Since our formula, right? So our formula, real quick here. So our formula has a plus and minus. And what we do is we choose the plus sign because we're in quadrant 2 and sine is positive in quadrant 2. That's why we choose it. Right? So then we notice our A value is 210 because half of 210 makes 105. So technically our angle measurement is 210. And then we put in the square root of, let's follow our formula. It's 1 minus cosine of 210, our original angle divided by 2. There it is. All right, so let's go with it here. So anybody with a unit circle here, I need to know the exact answer of cosine of 210. Now, once we know it's a plus sign, we can kind of drop that out already here. So, but let's see what we got. I think I got myself a negative root 3 over 2. At all over 2. Now, there's a little bit of work involved here when we do this. So first things first is we need a plus plus right here. Since we're adding, we got a plus plus. And then I want to simplify this as much as possible. And all these work for sine and cosine. They work very, very similarly here. So what we want to do is we want to get rid of this complex fraction first. So what we're going to do is we're going to multiply the top and the bottom by 2. And the reason just to get rid of this fraction here. So what does it look like on the next line down? It becomes the square root of. Now this 2 is going to multiply into here, which makes it 2. Going to multiply into here, which will actually cancel the 2's out. So now I have something that looks like this. And the bottom is 2 times 2 is 4. And in algebra 2, we learned that we could split these off into 2 different pieces. Is that right? Like this. And now the question is, what's the bottom going to be? I'm running out of space on my slide here. Oh, you know what I can do? I can slide this over. Ha! Look at this. I'm going to slide this over this way. Oh, now I got some room. So the top stays the same. No change to the top. It's square root of a square root of 3 over. Now the square root of 4 is just a 2. There it is. So it looks funny though, right? Probably one of the first times you guys see a square root inside a square root. A square root of 3 inside a square root of 2 plus square root of 3. And that's still okay. That is the exact same answer. That is the answer. We just figured out the exact same answer, or if we figure out the exact value of sine of 105. That's cool. And then usually students ask me, Mr. Ng, remember, we did this by the addition subtraction formula and did not look that way. That's interesting. We'll talk about that on Monday. How come these guys don't work that way? Okay. The other question that students come up was saying this, Mr. Hajiev, how come we need to develop this half angle formula? Because we can get 105, sine of 105 just by the addition of 60 and 45. Why do we need a half angle formula if I can just do it by the addition and subtraction? Well, let's exercise 2. Find the exact value of sine of 112.5 degrees. Huh. Now this one you could not do by the addition subtraction formulas. This time we're stuck. So let's see what we can do here. Let's see, what do we do? Let's multiply. Let's multiply 112 times 25 times 2. What will that give us? I need a calculator now. Let's see, calculator. What is 112.5 times 2? Oh, 225. Okay. So in order to get the exact answer of sine of 112.5, I could use double of that angle initially. So that's this 225 degrees. So here's the way we're going to write it. In fact, we just write it from beginning to end. We say sine of 112.5 degrees is the same thing as sine of about 225 degrees divided by 2. Parentheses if you like there. Okay, there it is. Then I can apply my half angle formula for sine. I got to choose plus or minus again. So what angle am I in? Or what quadrant am I in? I start off in quadrant 3. So because I start off in quadrant 3, my half angle will end in quadrant 2, and sine is positive in quadrant 2. I think we're good that way. So then we have a little formula that says this. Over that. That's our little formula. So now I need cosine of 225 degrees. Now we can keep the plus sign, we could drop the plus sign. But cosine of 225 degrees in quadrant 3 will be a negative root 2 over 2 over 2. Whoa, that's a lot of 2's. And we're going to do exactly what we did before. In order to simplify this out, what we do is we multiply the top by 2, this whole thing by 2, and we multiply the bottom by 2. And when we do that, we're going to get ourselves, let's see, 2 times this guy, it makes 2. Subtracting a negative, same thing as adding a positive, and then 2 and 2 cancel. This denominator of 2 and this multiplier of 2 cancels, and I'm left with this over 2 times 2 is 4. And notice the process is very similar to what we just did before. Split it off into 2 different radical forms, and then one of them is going to simplify. Okay, and that becomes 2. A lot of 2's here. But again, this is the exact answer for sine of 112.5 degrees. That is awesome. Right there. So that's the sine formula. Now the question is this: can we make a cosine formula for doubling the angle? Maybe. Let's go back to our first slide again. Question is, which formula should we choose to make a half angle formula for cosine? Haha, it's this one, right? It's the next one up. This one. So what we want to do here is we want to solve it for cosine. Let's rewrite it. Let me go back to this one again. 2 cosine. All right, now to move things over, we're going to add 1 to both sides. Divide by 2, divide by 2. Now you can either put the 1 in front or the cosine in front. And in order for the formulas to look pretty close together, what the book does, it puts the 1 in front of here. And we also have to take the square root. Remember, if we're the ones taking the square root, you got to put a plus or minus on both sides. But the whole point of doing this is for this and this to cancel. So let you guys copy it down. Let's turn it around. So this is still talking about the double angle formula, right? That's a double angle formula relationship. So let's make it the half angle formula. There it is. We have made the half angle formula for cosine, not sine. And the only change has been is there's a little plus sign instead of minus sign. I'm going to stop the video here. This is the proof of these guys. And there'll be another video here in order to do 3 quick examples of it. All right. Hopefully that made sense to you guys here. There is a tangent formula as well. Let me write that down just so we have it. In fact, tangent, half angle formula for tangent actually has 2 different formulas depending which one you want to use. You could either use it. We can develop this one on Monday if need be. Here, this is one formula: 1 minus cosine of A over sine of A, or another half angle formula for tangent you could use is Sine of A, 1 plus cosine of A. Whoa, okay, you can use either one of them. It doesn't matter. And for the most part, you also need a sine and a cosine for this one. You need a sine and cosine for this one. So really, it doesn't matter which one you use. You'll wind up with the same answer both ways. All right. Well, I wish you guys well on 3 problems ahead of you on the next video. And I'll see you guys on Monday.